Hello, welcome to our webinar today about the digitization of distribution grids, especially according to remotely indicated and controlled secondary substation as an central component in the grid. My name is Gerald Jacob. I'm the product manager of our department EORSys, which is about earth fault compensation and detection of Eberle here in Germany, in Nuremberg. At first, some general information about our company, as far as you don't know yet. We are founded in 1980, are located in Nuremberg, here quite central at the Franken campus. We have at the moment 140 employees, and our mission is clarity, openness, and fairness that we always emphasize. We are active at all voltage levels. You will see on one of the following pages as well. So from the low voltage, medium voltage, up to the high and highest voltage level. And we are operating internationally, so we are working together with local partners in around about 65 countries all over the world. We are repeatedly awarded and certified, so you can see we are here from Germany, a top innovator for several years, and also for Kununu top company certified, and especially important for our customers, certified according to ISO 9001 and ISO IEC 27001, which is quite important regarding our products. Here our product matrix. So as you might know, we have several different departments reaching from power quality, fixed and mobile devices, voltage regulation for the low voltage side, as well as for the medium and high voltage side. And today we have our webinar about, in our product group here, EORSys, about earth fault compensation and detection. And we today concentrate on earth fault detection, so with our devices EOR-1DS and EOR-3DS, as you can see in this row. Yeah, our agenda today splits into 5 different chapters. At first, I want to talk about the challenges for the electrical grid in times of energy transition. So here in Germany and Europe, we have a big energy transition at the moment, and I'm quite sure this is or will be also a big topic all over the world. Second topic, or second chapter, small chapter about the differences between simple secondary substations and digital and remotely operated secondary substations, to see the difference. And then we will see the devices EOR-1DS and EOR-3DS in detail in the chapters 3 and 4. Last but not least, in chapter 5, we will see an example, a very actual example about EOR-3DS in a digital secondary substation from a local DSO here in Germany called Netze BW. And we will see what can it mean, what does it mean to have a digitized secondary substation. Okay, at first, this is the situation in Germany. So what are the challenges in our times regarding energy transition? So for example, here in Germany, by 2030, at least of 80% of the electricity shall be out of renewable energies. At the moment, we are at a level of fixed 56%. And therefore, we of course have to install a lot more of onshore wind power and of photovoltaic, installed photovoltaic power. Yeah, this was the generation side. On the consumption side, we have also big changes and challenges. So beginning from this year, it's more or less not allowed to install new oil and gas heatings because you need at least 65% of renewable energy in new buildings. And since 2026, this will be also the plan for existing buildings. So all the heatings, they will consume a lot of electricity in future. A second big topic is e-mobility. So the goal, I doubt that we reach it. 15 million cars up to 2030 and 1 million public charging stations also until 2030. But this is the aim at the moment. Unfortunately, the electric cars, the registered electric cars, they stuck at the more or less same level. So I doubt that we reach it. But yeah, a lot of electric cars are on German roads up to now. So even this is a big challenge now. So these changes on consumption and generation side, they generate some pain points. And what are these pain points out of the view of this DSO, for example, of the DSO NetCB-W? In the medium voltage level, there's often no monitoring of the feeders. That means these secondary substations, they are installed in the depths of the grid, and there is no remote control, no remote connection, no remote indication, mainly nothing. On the other hand, the grid situation changes dynamically and several times a day. And if you want as a DSO to change the grid, you really have to send staff to the secondary substation and make manual changes of the circuit breaker or load breaking switch. So NetCB-W, and this we will see in the last chapter, therefore invented a new concept of digital, remotely indicated and remotely controlled secondary substation. Yeah, this we will see now also in the second chapter in theory. So the difference between simple and digital remotely operated secondary substation. So this is the standard, a simple secondary substation. On average, here in Germany, there are around about 100 customers connected to one secondary substation. There's no communication, no remote control. And if somebody wants to change something of the load breaking switch to switch it on or off, or even if there's an earth fault indicator installed in the secondary substation, one has to go there and look on the display of the device in which direction the fault was or is indicated. On the other hand, and this is completely new and a different concept, digital secondary substation. You can say there are four main topics which tell you that this is a digital secondary substation. First one is remote indication. So the whole secondary substation is digitized. You have a lot of state diagnosis and especially precise measurements of all cable fields. Second topic, remote control. To be prepared to change the network, the grid from a remote control center, you need to have the according actors, not only sensors, but also actors. So you need to control the circuit breaker from remote. Third topic here is the topic typicals or standards. So we are talking about thousands of secondary substations in the field. We are not talking about primary substations where you are going with a lot of people and doing commissioning individually, but you need to have standards because you want to install, for example, one secondary substation per day, and therefore the parameters and the delivery of the devices have to be fixed, have to be standardized. Why it is in this way is the amount of stations. We are talking about 10 to 20% of all secondary substations that shall be equipped with such a digital manner or in such a digital manner. For example, NetCBW has 25,000 secondary substations. 20% of these secondary substations are 5,000 secondary substations that shall be in a digital manner in future. And in each secondary substations, on average, there are 3.5 earth fault indicators installed. So if you multiply 5,000 secondary substations multiplied by 3.5, you come to a result of round about 18,000 devices in the end, only for this DSO installed in the field. Well, this is a lot. And this also has influence on topic 4, remote updates. Nobody has the time to go to 5,000 secondary substations and do firmware updates on 18,000 earth fault indicators if you want to change something. So you need to have a concept to do fleet updates regarding firmware, regarding parameters, regarding function extensions. And this is taken into account in the NetCBW concept. So as you can see below, NetCBW plans to have installed 1,200 digital secondary substations until 2030, so within the next 6 years. Okay, so this was general information about the challenges and the differences between simple and digital secondary substations. And now we come to our 2 different earth fault indicators. At first, we will have a look on the EOR-1DS, the economy indicator for analog secondary substations. So for these simple secondary substations, especially for retrofit. As you can see, our devices, of course, can be installed also in primary substations. We also have an EORD for primary substations, and the EOR-3DS, for example, is also capable of the requirements in primary substations. But we focus, especially the EOR-3DS, on these main or key secondary substations, so digital secondary substations, and the EOR-1DS is the device for simple secondary substations. This device is a simple and cost-effective retrofit solution. As you can see here on the left side, the indicator can be ordered directly with 3 of these current sensors. These are Rogowski sensors that can be mounted easily around the medium voltage cable and connected to the indicator EOR-1DS, and then you have an undirected short circuit indication, and also a pulse location is possible. If you install in addition also a measurement for the voltage, for example with this adapter cable on the right side that you can connect in parallel to a CAPTIS or Vega device, so voltage detection system device, VDS device, then you have an voltage measurement, you have a current measurement, and you have the possibility to have a directed indication of earth fault and short circuit. These sensors on the last page are not quite precise, but they help you to do easy short circuit and earth fault detection. In addition, our device, and this is a big difference to our competitor devices, the device is also capable of so-called low power sensors. There are low power sensors from different manufacturers. The most common are from Zilisco, Greenwood Power, ABB, and so on. And these sensors are available with two-wire connections, and these sensors can be connected to an EOR-1DS. These sensors come normally with a measurement class of 0.5, so a quite accurate measurement. And with these sensors, it makes sense to also measure power values, so active power, reactive power, and so on. And you can see these power measurements on the device, on the panel of the device, as well as you can send these values via Modbus RTU, which is available on device, or a serial protocol, to the central SCADA system. One short remark regarding these low power sensors, especially the low power voltage sensors. On the market, there are two standards. Some of these sensors require an internal burden of 200 kilo ohm, and some of them require an internal burden of 2 mega ohms. And depending on your sensor that you want to use, you have to order the EOR-1DS with the feature U6 or U7. So there's a small difference. In addition, the device can also measure directly PTs and VTs values, so classical values, as you might know them from primary substations. Therefore, you need certain adapters called C21, C25 adapter for the current, or the U10 adapter for the voltage measurement. It's also possible to equip the device with a DIN rail adapter to mount it on a DIN rail directly, as you can see here on the left side. By second half of this year, we will change these two adapters to one adapter, a modular adapter that you can directly mount on the device, so voltage and current sensor on the device itself, or you can also mount this combined adapter separately, for example, with a 3-meter cable on the DIN rail. So this will follow in the second half of 2024. Here a small overview that you can also find in our datasheet about the possible algorithms for earth fault detection and short circuit indication, depending on the measurements that you have. For example, in the first row, you can see when you only have 3 times the measurement of the current, you have as possibilities the pulse location in compensated networks and the undirected short circuit and short circuit to earth indication. As soon as you install and measure in addition also all 3 phases of the voltage, you have the whole range of algorithms available. And so on. There are also different options regarding CBCTs and so on, depending what you're measuring. Different algorithms are possible. This is also a big difference to our competitor devices. The device has fault records on board. Here is set with fixed record time, so you can parameterize it and then it's fixed. So you can only record 200 milliseconds, but you can also record 4 seconds, for example. And in addition, the device also has a logbook, and both the fault records and the logbook are saved on an internal SD card. So you, if you want to have access to this logbook and fault records, you have to remove the internal SD card and read it out in your laptop. Here an example where you can find this SD card. So you have to remove the front plate with a screw. You have to unscrew this one, remove the front plate, and then you will find the SD card here just above the key, the turn push key. This page also shows something else. This shows how you can set up the parameters in the device. There's no software available for this device. All the parameters have to be set on the device itself with this turn push button on the front. What you can do is you can clone or copy this parameter setup of one device to a second device. So you set up the complete device, remove the SD card from the first device, insert it into the second device, and then load the complete parameter setup in the second device. This is one possibility. A second possibility that is often used from customers is that you give us your parameter setup, you get a certain specific article number for your device plus parameter setup, and then you can order the device pre-configured with your parameter setup. As an example, our local DSO here around Nuremberg, they order always the same device, but they have 3 different parameter setups, and therefore they have 3 different article numbers that they can order from us directly. So they always get the pre-configured device. Then there was a former device, EOR-1D, that was equipped with an internal battery for indication of an earth fault or short circuit in case the supply voltage was interrupted. We always had discussions about maintenance intervals and so on. So we decided with the EOR-1DS, so the actual device, that we will not use a battery anymore, but we use a supercap, so a long life capacitor now inside the device. So you don't have to take care of the maintenance of the device. The indication is available on the panel for at least 4 hours, and the 4 hours is really a worst case scenario that we calculated after 15 years the device being installed, and in addition when you are using an additional indicator light. So there are 3 different indicator lights available that you can wire to the device on the back and install this indication light somewhere outside of the secondary substation, so you don't have to open the door of the secondary substation and you directly see the direction of the fault or whether there is a fault at all. And even with using this indication light, we guarantee 4 hours of indication. And one remark regarding the Modbus RTU interface. The Modbus RTU interface, in case of such an power supply interruption, will send you the latest data for example, 30 seconds, and then will quit the indication, and it will automatically recover the Modbus RTU as soon as supply voltage is available again. Here a short overview of the main features of the EOR-1DS. So we have earth faults and short circuit indication, directed and non-directed. As explained, this is depending on whether you only measure the current or you measure the current and the voltage in addition. We have fault records and logbooks on the SD card for easy fault analysis. We have 4 relays and 2 binary inputs on board. We have the opportunity to also connect high accurate low power voltage and current sensors at the device. We have Modbus RTU protocol on board, power recordings, especially in connection with low power sensors. This is useful. Then we have a wide range power supply, so you can supply the device with AC or DC up to 260 volts. And we have an internal long life capacitor for an indication for more than 4 hours. And short outlook regarding the firmware. The reactive power direction method sinus phi and the active power direction method cosinus phi, which is also called wattmetric method, will be available in the firmware by also second half of this year. So we are at the moment developing this. And this is not depending on the hardware, this is just a firmware feature. Okay, next chapter now about the big brother of the EOR-1DS device, the EOR-3DS device. That is focusing on these main or key secondary substations. Yeah, this device is not only equipped with a serial protocol like Modbus RTU as the EOR-1DS has, but this device is really a digital device. And 3 digital functions you can see here regarding SCADA, security, and switching. So the first one, SCADA via Ethernet. We have a lot of protocols, standard protocols for SCADA communication. For example, a 104 protocol, 61850 Goose, Modbus, TCP, DNP, 3 via Ethernet, and the 2 latest protocols we implemented are based on the protocol MQTT. There are 2, MQTT M&O, which means management and operations, and IIoT, which means Industrial Internet of Things. We will see in the 5th chapter why we split it in these 2 different protocols. The one is for maintenance, so for firmware updates, parameter updates. The second one, the IIoT, is more to have all these data on a second network for other departments like asset management. The device has 2 Ethernet faces, Ethernet interfaces on the back and also with an adapter on the front. So in total, we even have the possibility of 3 Ethernet interfaces, but 2 are on the back. Available, for example, if you want to have different networks for remote maintenance and SCADA communication. And as said before, the remote maintenance is especially available via the management and operations protocol, which I will explain later on. Second big topic is security. So we have encrypted communication, including certificate handling. Yeah, as soon as you have Ethernet protocols, you have to take care of IT security. And therefore, we also have, in addition, a user role model regarding the panel and also the TCP/IP communication with our software. And third big topic, switching. The device is meant for digital secondary substations where you also want to have remote indication and remote control. And for this remote control, we have in total 4 relays, monostable relays in the device, and 6 binary inputs and PLC functionality. That means the switching function, for example, can be customer specific if required. Regarding the installing options, of course, this device is meant to be installed in compact switchgear stations, as you can see, for example, on the left side and on the right side. On the left side, this is one of ABB without the front plate of the compact switchgear station. And as you can see, there is a frame just above an empty frame just above the VDS system, where you can install this device, EOR-1DS or EOR-3DS. Then you can also equip the device with DIN rail mounting adapters, as we saw for the EOR-1DS. And on the right side, we see there's also the possibility to order such a compact switchgear station with a low voltage compartment on the top, where you have separate doors per cable field and the transformer field. And yeah, this is the easiest way. You have a lot of space inside this low voltage compartment. Regarding sensors, we have different options. We have even wider range for sensors compared to the EOR-1DS. First, very comparable is here shown on the left side, so low power sensors with 2-wire connections. As I said before, at the EOR-1DS, there are different manufacturers like Zelisko, ABB, Greenwood Power that offer such sensors with 2-wire connection, class 0.5. And as you can see from the back of the EOR-3DS, you have a 26-pole terminal plug, X5, and here you can connect all your, in total, 4 voltage sensors and 4 current sensors if you want to. Sometimes you only want to measure 3 phases, 3 voltage and 3 current phases, but you can also measure the 0 sequence voltage and the I0 directly with a CBCT if you want to. What else can we see? Despite the X5, on the X5 there are also 4 binary inputs on this terminal plug. Then X6, we also have 2 additional binary inputs that are not only up to 60 volts, but up to 132 volts. Then we have X4, which is the terminal for RS485 for serial protocols, serial interface. This is an order feature. So you can order the device also without X4. X2 is the supply voltage, and X1 are the connectors for the 4 relays. Here, PE, earthing connector, and 2 Ethernet phases as told before. We have an ETH0, which is the first one, and ETH2, which is the third one, and in between we have an ETH1, which is the Ethernet interface in the front, but you need a special adapter to use this Ethernet interface. Okay, and then let's come to the right part of this page. Second option of sensors that can be connected to the device, and these sensors are with RJ45 connector. As you can see, for example, Siemens SI bushing that comes with such a RJ45 connector, or different sensors from ABB. The Siemens SI bushing and the ABB KEVCY are bushings that are installed in the compact switchgear directly, and inside these bushings the low power sensors, voltage and current, are already installed, and out of this bushing comes an RJ45 that can be directly connected to one of the 3 phases of the EOR-3DS. From ABB you always also have the possibility to install separate sensors, for example here a voltage and a current sensor. These sensors come also with an RJ45 connector, can be connected with a special adapter to one RJ45, and then you have once again on one RJ45 current and voltage measurement of one phase. So of course, our device wants to measure all three phases, as you can see, L1, L2, L3. So in a compact switchgear station in each field, there are either 3 of these Siemens SI bushings installed or 3 of these ABB bushing sensors installed, or 3 current sensors and 3 voltage sensors in one field. Okay, so these are low power sensors, also with class 0.5 and RJ45 connection. And there's one small difference that you will see here. The X6 connector is different because we had no space left for the binary inputs because we removed here the 26-pole terminal plug. So the 6 binary inputs are here, and we have 2 routes only. So 2 routes, 1 route for binary input 1 and 2, and 1 route connector for the binary inputs 3 to 6. And everything else is very much the same. One thing I want to mention as well is here a small slot, which is the SD card. So compared to the former devices of the EOR-3DS, we also removed here the battery. As you might know, there was a small battery for the internal clock that we removed as well. So this is also buffered via a supercap, and all which is left here is the SD card, where we save our fault records and logbooks on. Okay, so some very short information about sensors of ABB and Siemens here. The device or the sensors, the low power sensors from ABB, they have class 0.5, so the accuracy is, or inaccuracy is below 0.5%, and our device itself has also an inaccuracy of 0.5%, below 0.5%. So we can guarantee device plus sensors have an inaccuracy below 1%. That means an accuracy, measurement accuracy above 99%. Because these sensors of ABB are long time on the market. At first, they were according to the standard IEC 60044, and the pinning was a little bit different. Here, the current pins were on pin 4 and 5. Now they changed also to the new standard, which is 61869. And in this new standard, the pinning of the current has changed, unfortunately. So the pinning of the current is now on the pins 1 and 2. But you don't have to care about this fact, because internally, when you order the device for ABB sensors, the pins 1 and 4, as well as 2 and 5, they are short-circuited in the device. So you can use sensors according to the old standard or to the new standard with our device. Here in comparison, the Siemens SI bushing, this one is relatively new, so directly regarding or according the IEC standard 61869. And as you can see here, the current is on the pins 1 and 2, and there are additional pins used, 4 and 5. And what are they used for? They are used for an internal PT100. So a temperature sensor that is read out from the EOR-3DS. So the EOR-3DS can measure not only the voltage and the current per phase, but also the temperature of each bushing. So this is a quite nice feature. And compared with the competitors, there's also one feature I really want to emphasize here. The sensors come ex works with a so-called sensor configuration file, including all correction factors. So normally each sensor has an amplitude correction factor and a phase correction value that you normally have to set in each device per sensor. So 3 times voltage, 3 times current measurement. For each of these 6 measurements, you have 1 amplitude correction factor and 1 phase correction. That means in total you have 12 values that you have to configure in each device so that the sensors measure perfectly. With the Siemens SI bushing, you don't have to care about that because they upload such a sensor configuration file on the device, and the device automatically takes these correction factors into account and measures perfectly since the first minute. So you don't have to parameterize anything. You don't have to insert all these 12 correction factors per device. So very, very user-friendly from my point of view. Yeah, the device is also usable with the adapters we saw from the EOR-1DS. It's more or less just the same. So if you want to use this device in primary substations mainly, you can also measure directly 1 ampere, 5 ampere, or 100 volt, 110 volts with the according adapters. And also here, we will change during the second half of the year to this combined modular adapter that can be also mounted easily on DIN rail as a package. I already said some words about the possible protocols that are available, not only Modbus RTU, but also Modbus TCP, 103 protocol, I did not mention yet, 101 protocol, 104 protocol, DNP serial or via TCP, 61850 Goose. In future, we could also implement 61850 MMS. But at the moment, yeah, our feedback from our customers is that 61850 MMS is not required so far in secondary substations. And the newest 2 protocols, MQTT, Management and Operations, and IoT, that we will see in the 5th chapter, as I said. And one new information is here that you can use the EOR-3DS as a SCADA gateway via Modbus RTU. And this is not limited to our Eberle devices. You can also use other devices, but here in the example, you can see 1 EOR-1DS devices, for example, in cable fields 2 and 3, and they are read out via Modbus, though they act itself at Modbus slave and are read out from the EOR-3DS, which acts as a Modbus master. So all the information are transferred to the EOR-3DS and then can be directly sent via another protocol, for example, Modbus TCP or 104 protocol to the central SCADA system. It's even possible to recalculate some values. So the PLC functionality can be also used to, for example, calculate the total amount of power of the whole station. And this calculated value can then be sent to the central SCADA system. So some kind of edge intelligence can be installed and implemented here. Yeah, as I said, it's not limited to Eberle devices. You could also, it makes maybe no big sense. You could also read out other EOR-3DS devices. You can read out EOR-1DS devices, or you can connect any other Modbus RTU speaking device, for example, and Siemens motor control unit is also available with Modbus interface. this could be also connected here. Yeah, our core competence of the device EOR-3DS, of course, is the fault detection and location. We have the same algorithms on board as the EOR-1DS and even some more, because the device is not microcontroller based, but a Linux based device with more resources and capabilities. So compared to the EOR-1DS, the device also has the QU2 transient method, which is very reliable and always used, but can be only used when the Earth fault begins, and has in addition the QUI for restriking faults, which is not available in the EOR-1DS. So for cable networks, this is quite useful. And then we have the reactive and batmetric method, cosinus phi and sinus phi, that will be implemented by second half of this year, also in the EOR-1DS. We have the pulse location that we always also have in the EOR-1DS. And in addition, we have here an harmonic method that uses in compensated networks harmonics to use it equivalent to the sinus phi algorithm. So this harmonic method is also only available in the EOR-3DS and not in the EOR-1DS. And of course, we have short circuit and short circuit to Earth location on board. And we are also working on another Earth fault location method, but this is in preparation at the moment. PSD functionality I mentioned on the first page. So for switching, for example, customer-specific requirements, we can use a free programmability in the device. Other examples would be crosswise calibration of feeders. So if you have single devices that measure the voltage not very accurate, then you could cross calibrate it via Ethernet if required. Or for example, as mentioned with the Modbus master functionality, a calculation of the total power or any other requirement could be implemented here. So the main features again now of the EOR-3DS in the overview. So we have sophisticated Earth fault and short circuit indication with additional algorithms. We also have fault records and logbooks here that can be saved also on an SD card, but can be also read out via software from remote. Of course, fault records can be up to 100 seconds if you really want to use that. Standard is 2 seconds. It's a switch panel mounting device with 4 relays and 6 binary inputs, especially for remote control of compact switchgear stations, and meant for that. We can, of course, connect low power sensors of a lot of different manufacturers, not only sensors with 2-wire connection, but also sensors, especially from Siemens and ABB with RJ45 connector. We have PSD functionality on board. We have a really wide variety of different SCADA protocols, including this Modbus master functionality that goes in the direction of an SCADA gateway. We have 2 protocols based on MQTT, so for a cloud application and for remote maintenance of the device that we will see in the 5th chapter now. And one difference I want to emphasize compared with the EOR-1DS. We saw at the EOR-1DS that we have AC and DC power supply available. Here with the EOR-3DS, we only have DC, a DC wide range power supply. That means from 20 volts DC to 148 volts DC, which is available. We decided for focusing on DC because this device is meant for digital secondary substations, and here you always have an uninterrupted power supply available based on DC. So now the often mentioned example, the new standard of a digital secondary substation of the DSO NetCPW here in Germany. And how does it look like? This was the first installed secondary substation of this FFU2 standard in April 2023. So yeah, last year in the near to Stuttgart here in Germany. As you can see here, this is the secondary substation in total, and here the compact switchgear from Siemens, and in the low voltage compartment here you can see our devices as earth fault indicators installed. Here also a big photo, and from the other side you can see here, for example, the transformer here on the right side that you can't see now. For example, there is the low voltage side of the low voltage feeders. NetCPW required in their tender a so-called PIDO device. Yeah? This PIDO device means a process interface and detection unit. What does it mean? Detection unit is our device. Our device is an earth fault and short circuit indicator or detection device, but they wanted to have more, and this I want to explain here. What does it mean to have not only detection unit but also process interface? On the one hand, of course, this is our main topic, integration of several functions. So location means earth fault location, remote switching with the relays and the binary inputs, and measurement. Our device can measure with an accuracy of more than 99.5%. The device needs to be able to connect precise and economical low power sensors, like the Siemens iBushing, that is directly the bushing with integrated low power sensors. The device needs to support several SCADA protocols for, on the one hand, the central control center, and on the other hand, this IoT protocol for further data analysis, yeah, in the departments of asset management, grid planning, and so on. Therefore, the device is connected via Ethernet and has to support all current IT security features, including certificate handling, encryption, and so on. It needs to have some compact design, yeah, comparable with our competitors, so that you can mount it directly above the VDS system or in such a low voltage compartment above. Future-proof hardware. This is a big difference regarding our competitors. Our competitors, honestly speaking, they also have good devices, for example, the company Horstmann, but their hardware is not very future-proof. This hardware is designed just for the tasks this devices shall do at the moment. If you want to have a device installed in the feed that is also capable of new features in 5 or 10 years, additional algorithms or advanced sophisticated programs, PLC functionality, and so on, then you have to choose a hardware that has some kind of resources on board. And last but not least, scalability. So you need to have thousands of devices being delivered and installed within a short time. So you need to have the possibility as a manufacturer to deliver the devices with the right parameters, with the right SCADA parameters, with certificates, and so on. Everything has to be standardized, fixed, and then you deliver these standardized products. So now we come to the concept itself regarding our devices and the compact switchgear station. This is not the complete digital secondary substation. As I mentioned, there's also a low voltage side that is not shown here. We focus now on the middle voltage part of this digital secondary substation, and especially here regarding our earth fault indicators. So this type of a digital secondary substation is a real true all digital secondary substation, though there is really no serial protocol used at all. There are other DSOs that are using Modbus RTU internally inside the secondary substation, not so with the standard of NetCBW. Every device is connected directly in a digital manner via Ethernet, and all analog signals are digitized locally, directly in the regarding feeder. So for example, in the cable field 1 that you can see here on the left side, all the 6 binary inputs are used for the earthing switch and for the load breaking switch and for the remote control button here and for the DC. For the DC. So you can see here in the overview the compact switchgear station in the middle. You see some arrows in each cable field. 3 bushings are installed for all 3 phases, and they are directly connected via Ethernet cable to the earth fault indicators, EOR-3DS. We have here a remote control, so a motor control unit installed in the cable fields, and via the 104 protocol, the devices get a command to open or close the load breaking switch. They pull the relays in direction of the motor control unit, and in the end the load breaking switch is switched off and on. So all the devices are connected to the central control center via a classic SCADA protocol, in this case 104, for measurements, for indication, and especially for switching operations. As you can see, there are 2 other protocols in parallel. One of them is the mentioned IIoT, Industrial Internet of Things. Here we don't have a one-to-one connection like in the SCADA protocol path, but we have IoT is working a little bit different. All the data of IoT are sent to a central broker, and a lot of different data user can then subscribe these data as they want to. For example, the asset management or grid planning, they can just subscribe the data they want to use. And it's a different network. So the grid planning asset management has no access to the central control center. And in addition, here the opportunity is to send a lot more information to this central broker, to this IoT broker, compared to the SCADA. The SCADA maybe is not really interested in the transformer temperature or the door contact of each secondary substation. This might be interesting for grid planning or asset management, for example. So, and in the end, we also have a green path, which is called management and operations, which is also based on MQTT and HTTPS for remote updates of parameters and firmware. And with firmware, also new functions can be implemented. All these MQTT-based protocols, management and operations and IoT, they are encrypted with the help of certificates. So as you can see, management and operations, IoT, they always have certificates on board. And in the network of the DSO, there's an EST server, enrollment over secure transport. So this is a certificate server to automatically renew the certificates. Yeah, in between here you can see also routers. So this is via GSM, LTE, or in future here in Germany and Europe, 450 megahertz prepared. The connection is secured in addition via a VPN tunnel, and we have an uninterrupted power supply with 24 volts DC here, and an RTU and an IoT gateway to individualize the topics and data points of each device. Yeah, regarding the screen path management and operations, you need a central software to distribute these parameter updates, firmware updates. And NetCBW, for example, uses software, IoT software of the company Software AG, which is called Cumulocity IoT. But our device has also a second alternative. There's also a license-free open source alternative, which is called ThinkSpot IoT. So you can use both of them to do fleet updates and fleet firmware updates. Here's some further information, because we are talking about thousands of devices, not only short circuit indicators, there are also other devices in the secondary digital secondary substation that shall be implemented in this central IoT software. And here you can see the onboarding process. So on each device in the secondary substation, there's a QR code that can be scanned with an app, for example. And these information are transferred to the central certificate center. And the certificate center compares the information from the QR code to the information that are stored in the certificate. So we deliver our devices with a manufacturer certificate, and these information of QR code and certificate are compared. If they match, the device, the EOR-3DS, for example, gets an additional certificate, and so-called operator certificate. And with this certificate now, the device is able to establish the connection to MQTT IoT and MQTT M&O. And in this Cumulocity IoT software, for example, automatically registers and bootstraps. It's called. It's a bootstrapping process. So the device will be automatically added in the software. Nobody has to add the devices manually. So this is a real nice concept, especially because we are not talking about 10 or 20 devices, but we are talking about thousands of devices that we want to have access and control of. Some additional features. I don't want to go too much into detail, but one big difference that one has to be aware of is we have our own software called AE Toolbox. With AE Toolbox, we do the parameter setups, and we have an export functionality. With this export functionality, there comes out of our own software a zip file. And this zip file, the complete parameter setup with Ausfault parameters, SCADA parameters, PLCs, so PLC functionality, and so on. This is all stored in one zip file, and this zip file can be then sent out to all the different devices connected to the Cumulocity IoT. So we only send complete zip files via this central IoT software. And in addition, in laboratory, we need our own software AE Toolbox to prepare these parameter setups. And the same is for firmware updates. Firmware updates are always some kind of zip files that can be distributed then to different devices. And the charm of this Cumulocity IoT or ThinkSpot IoT central software is you can build clusters. So you don't have to make firmware updates on each device on its own, but you can do some grouping. You can group your devices. For example, you have a network grid north, grid south, grid west, grid east, and you can distribute the firmware to all the devices in the group of your grid east at the same time. So that makes it easy to distribute firmware and parameter updates. In addition, you see in this IoT software a lot of additional information, CPU usage, health status, and so on. If you have a problem with one device, then you can go into detail, read out logbooks, for example, of the device to see what does the device has a problem. So for fault elimination, for remote maintenance of the devices, the software can be used as well. And here one last example, ThinkSpot IoT. They look very much the same compared with Cumulocity IoT. You can do your own dashboards, for example, here with memory usage, CPU usage, CPU temperature, and the heartbeat. That means since which time the device did not reboot due to a firmware or parameter update or any other reason. And ThinkSpot IoT is, for example, used at the DSO EVN in Austria. Yeah, you have a lot of additional information. For example, the complete firmware update process can be seen in the history. So finally, I want to end my webinar today by the question, what is the benefit of a digital secondary substation with such remote update possibilities? There are three main topics that you can tell. First one, state estimation. You want to have precise middle voltage measurement values via SCADA and IoT for asset management as well as for the central SCADA system. And you want to have these data for state estimation of not measured grids based on comparable measured grids. So the task is not to equip 100% of all digital secondary substations in such a digital manner, but only to equip 10 to 20% to do state estimation for the rest of the network. Yeah, this is the first big topic. Then big topic for the future, self-healing grids. If you want to have the goal in future of self-healing grids, you have to install at first the sensors and also the actors in your field. And this is done by such digital secondary substations. So not only remote indication, but also remote control. And if you have enough sensors and actors, enough digital secondary substation installed in a certain field of your grid, then it will be possible in future to detect faults in the middle voltage grid, automatically isolate them automatically, and switch them out automatically. So yeah, to achieve this goal, you need to install first the sensors and actors. And then might be the most important one, cost-efficient operation. If the demand is there, the requirement, because of the dynamical grid situation, to change the grid all the time, yeah, you need to be prepared for bulk remote updates, parameters and firmwares. You can't install thousands of devices in your grid without remote access, without the possibility to react on requirements that you are not aware at the moment. And if you want to be ready to change something, to adapt your system, your parameters within the next 5 or 10 years, you can't go there to 5,000, 10,000 stations and parameterize and do updates on 20, 30,000 devices. So this is not possible. Everybody has problems to find enough personnel. So you need to think about a central system where you can do these updates in a short time. And as you can see here in the middle, the operating costs per digital secondary substation. This is a graphic from NetCBW. Of course, the initial costs are quite high. Yeah? The production backend with this certificate server, with the license fees for IoT software, for example, you need to have some colleagues that are really specialists in IoT and IT security. So the initial costs are high. That is clear. That you can see in the first one here. If you have only 200 secondary substations or want to install 200 digital secondary substations, the costs per substations are quite high, but they reduce immediately and rapidly among the additional installed secondary substations. So if you come to a number of thousands or more secondary substations, the costs per secondary substations reduce a lot. And one thing I'm allowed to mention is that NetCBW, for example, also thinks about offering this as a service for other DSOs, at least here in Germany, because they are very aware of that the initial costs, the concept phase and so on, it takes a lot of time, it takes a lot of money, and not every DSO has to invent this once again. So if you're interested in NetCBW, for example, will offer this also as a service. Okay, then thank you for your attention. Took a little bit longer than 1 hour. I hope you enjoyed this webinar. And if you have any further questions, feel free to contact me or to contact your local partner. I'm looking forward for your questions regarding mail or telephone or our social media accounts. Thank you for your attention. Thank you for joining our webinar, and see you. Bye.